Addition with fractions. Like denominators. Like means that they're the same. So like is another name for the same. Two or more fractions are said to have like denominators when they both contain the same denominator. So 5/12 and 1/12 have like denominators. The denominators are both the same. Adding fractions with like denominators. So first we're going to talk about adding fractions with the same denominator, and then we'll talk about adding fractions when the denominators are different. So when we have the same denominator, our first step is we're going to add the numerators, that's the top number, and then we're going to write that result over the original denominator. So write the result over the same like denominator. And then if we can, we'll reduce if possible. Like always, we're looking at a problem. If you think you do it already, just go ahead and pause the video and always try to work the problem out on your paper. And then click back on play when you're ready to keep going. Okay, so 5/12 plus 1/12. So we're going to go ahead and add the numerators. So 5 plus 1, that will be 6. And the denominator stays the same. Now, can we reduce that fraction? And you could use either method. You could use the prime factorization method, where you find the prime factorization of both numerator and denominator. You know, it takes a little bit of work, or you could try to find a number that goes into both numerator and denominator, the largest number, the greatest common factor. When the numbers are pretty small like this one, it's probably easier to do that. So what number goes into both 6 and 12? What's the biggest number that goes into both 6 and 12? Yeah, that's right, 6. Now, if you divided by 2 and then by 3, it would still work out. You'll just take more steps. So you should get an answer of 1/2. Okay. Let's try another one. Find the perimeter of the given triangle. So now it's an application problem, but remember, perimeter means to add all the sides. And notice that all the denominators are the same. So we're going to add 9/17 plus 12/17 plus 15/17. And all the denominators are the same, so we're going to add all of the denominators. We're going to add all the numerators and write it over the original denominator, 17. So go ahead and add 9 and 12 and 15. And you're going to put that number over the original denominator. So you should get 36. And that is what's called, let's see, what is that called when the numerator is greater than the denominator? Right, it's called an improper fraction. And that doesn't sound right? 36/17. So we're going to divide the denominator into the numerator. So go ahead and change that into a mixed number by dividing the denominator into the numerator. So 17 into 36. You always do that when the top number is larger than the bottom number. And then the remainder is going to be the numerator. The whole number is going to be the whole number. The quotient is going to be your whole number. Okay, so you should get 2 and 2/17, because 17 goes into 36 twice. That's a 2 in front, with a remainder of 2. That's a 2 in the numerator. And the 17 that stays in the denominator. So when we add up all these three sides, we get 2 and 2/17 inches. I should have put inches. Sorry about that. There we go. Inches. Oh, you should have your units for your answer. Okay, let's go on to the next problem. Oh, I didn't forget the answer. I put it in the box in the next step. Okay, let's go on to the next slide. Unlike denominators. Okay, unlike. Different. Unlike denominators, two or more fractions are said to have unlike denominators when they both contain different denominators. That is bad English. When they both contain different denominators. So, number one, adding fractions with unlike denominators when they're different. Number one, find the lowest common multiple for the denominators. And we're going to call it the LCD this time. Instead of LCM, we're going to call it LCD because we're talking about denominator. Okay, so lowest common multiple, we've talked about common multiples in the previous section, but we're going to call it the LCD this time. And if we use the word LCM, it's okay. Nobody's going to really care about that. LCM, LCD. Write each fraction as an equivalent fraction using the LCD for the denominator. And in arithmetic, some students prefer to write the fractions vertically. When we get to algebra, this may change. We want to write it horizontally. But I think at that time we'll make the change. I think it's probably easier to go ahead and go with what's more traditional and write the problems vertically. I think it'll be more successful right now, and then we'll be able to make that conversion later. So what we'll do now is we'll write it vertically. But if you want to leave it horizontally, maybe you've learned it that way in the past. Also, if you're from another country, people are usually used to doing it, leaving the problem horizontally. So that's perfectly fine. Number 3, add the numerators. Write the result over the LCD. And then number 4, reduce if possible. So numbers 1 and 2, those are the new steps, and 3 and 4, that's the same thing we were doing before. Okay, let's do a problem. Add 5/12 plus 3/8. So notice that the denominators are different. They are unlike. So our first step is find the LCD. Okay, so to find the LCD, we need to find the lowest common multiple of the denominators for 12 and 8. Now, some people may be able to look at those two numbers, 12 and 8, and find the lowest common multiple of 12 and 8. You might be able to do it in your head, and that's fine. We're going to go ahead and do the prime factorization method for doing that. So you do the tree for 12, and then do the tree for 8. I'm not going to show that, but I'm going to show the result here. So 12 is 2 times 6, and 6 is 2 times 3. So that's 2 2's and a 3, and 8 is 2 times 4. 4 is 2 times 2. So 12 is 2 times 2 times 3, and 8 is 2 times 2 times 3. So it's good to write that in a row. Being very methodical with your math will just increase your success. It will just increase your success in mathematics. Okay, so now your LCD, remember you go through each prime number and you write down each prime number, the greatest number of times that it occurs in either row. So what's the greatest number of times the 2 occurs in either row? That's right, 3 times. There's 3 2's in the 8. So there's going to be 3 2's. And what's the greatest number of times that 3 occurs in one row? That's right, once. So there's 3 2's and 1 3, and that gives you 24. So 24 is your LCD. That makes sense. 12 times 2 is 24, and 8 times 3 is 24. 12 and 8 both go evenly into 24. Sometimes people start thinking, when they see LCD, they start thinking of what goes into 12 and 8. And that might have been some of your first thought when I said LCD. Find the LCD of 12 and 8. Oh, what goes into 12 and 8? But it's not what goes into 12 and 8. It's what does 12 and 8 go into evenly? I don't know if I said that right. What number does 12 and 8 divide evenly into? Okay, let's go ahead and write the fractions. We're going to write it as equivalent fractions. That's our second step. And then we're going to write it vertically. Okay. So 5 12s plus 3 8s. And let's put that 24. That's going to be our new denominator on the side. If you wrote it horizontally, you would write the 24 below each fraction. Okay, so now what we're doing is we're saying 12 times what number is 24? So that would be 2. So then we're going to multiply the top number by 2, the numerator by 2. And the bottom number we'd multiply by 3 to get 24, so the top number by 3. So on the numerator we get 10, and the numerator of the bottom fraction will get 3 times 3, that'll be 9. So we have written both of them as equivalent fractions, and now we could add both numerators. So add the like fractions. See, this is what we had in the last problem, the last couple of examples, is the denominators were already the same, right? They were both 12 in the first problem and 17 in the second problem. Now in this one, they're both 24. So therefore, we could go ahead and add the numerators. That will be 10 plus 9, 19 over 24. And it doesn't reduce, so we're all done. Okay, let's move on. 14 and 18, those are our two denominators. Right, let's find our LCD. This one's a little bit harder. Probably can't see that one in our head, what our LCD is. So definitely let's do the prime factorization for each number. Again, you might want to pause, work on the prime factorization, find your LCD. I think you can do this one on your own now, and then come back when you're done, and we'll go through the problem. Okay, so 14 is 2 times 7, and 18 is 2 times 9, and 9 is 3 times 3. So we got 14, 2 times 7, and 18 is 2 times 3 times 3. So our LCM for each prime number, we write it the greatest number of times that it occurs in any one row. So what's the greatest number of times that we're going to write down the 2? Right, just once, because it only occurs once in the top row and once in the bottom row. The most number of times it occurred in one row was just once. So 1, 2. What's the most number of times it occurred? The 3 occurs in one row? Twice. And the most number of times the 7 occurred in one row? Just once. So 1, 2, 2 3s, and 1 7. And that looks like it let's multiply that out. 126. 126. So we're going to write our fractions vertically, and that's going to be the new denominator that we're going to write over to the right of each denominator. Okay, now when you're trying to figure out 14 times what number is 126, look at what 14 is. 14 is 2 and 7, right? So if you go over here and you look at, well, here's 2 and here's 7. So if you cross out 2, cross out 7, what's left? 3 times 3 is 9. So that must be 14 times 9. Let me erase that now. Okay, let's do that with the next one. 18. 18. What is 18? 18 is a 2, a 3, and a 3. So cross out a 2, a 3, and a 3. And then tell me what's left. So cross out the same numbers in your LCD. That we have 18 right here, right? 18. Here's the prime factorization of 18. 2, 3, and 3. So 2, 3, 3. What's left? 7. 18 times 7 is 126. Okay, I'm going to go ahead and erase that so I leave it alone. Okay, so that's a little trick that'll always help you out if those numbers get too big. Okay, so 3 times 9 is 27. 5 times 7 is 63. Oops, 5 times 7 is 63. I don't know where I got that from. I think I multiplied 9 times 7. 5 times 7 is 35. Anyways, that little trick I just showed you, it really comes in handy when the numbers get large. And you probably got real confused right there. Keep working on that one. Keep looking at trying to see an easy way of doing it. Otherwise, you have to, like, 14 times what number is 126? You have to divide 14 into 126. So you could always do that, and you could always say, oh, 14 goes into 126 how many times? You could just start trying to figure out 14 times 7 times 8, but that's a little shortcut. It's just use the numbers over here to figure that out for yourself. And now we can go ahead and add the numbers. 27 and 35. 7 and 5 is 12. Let's 2 carry the 1, 62. And then that reduces 62 over 126 by 2, right? And so that'll give you 31 over 63. Yeah. Okay, so let me just go back to this again. Here's the 14, right? Here's the 14. 14 is 2 and 7. So cross out the 2 and 7. And then what's left? The 2 3s. Multiply that. That's got to be this number. Okay. And do the same thing with the other one. I'm going to erase it. $18. Here's our 18. 18 is 2, 3, and 3. So cover up 2, 3, and 3. And what's left? 7. There's our 7. Let's go to the next slide. Last problem. Find the perimeter of the given rectangle. Rectangle this time. Last time was a triangle, this time rectangle. So if we have a rectangle, we have to add up all the sides. Don't forget, there's 4 sides on a rectangle, so that means we have to consider this top side, which is 3/8, and this side on the right, which is, the top side, which is 5/6, and the right side, which is 3/8. So even if it's not written in, it's the same as the side opposite of it. Okay, so we're going to add all 4 sides. 3/8 plus 3/8. I just wrote down the numbers, but we'll put in the units at the end, which is, in this case, it's inches again. Okay, now you have 2 options. You could either add the 2 like fractions, the 2 pairs of like fractions, and then add those, or you could add all at once. It's up to you. So you could add the 3/8 plus 3/8, and the 5/6 plus the other 5/6, and then add those 2 results together, or you could add them all at once. I'm going to add them all at once, just show the 4 fractions all at one time. But it doesn't really matter. It's really just preference. This is just kind of a little bit, maybe it's kind of maybe it doesn't look that good because it's 4 fractions all vertical. But anyways, 8, 8, and 6 and 6, those are our denominators. 8, 8, and 6 and 6. Let's see. We could probably see the LCD in our head without working it all out. What's our LCD for 8 and 6? What number does 6 and 8 divide evenly into? 24, right? 8 goes into 24 and 6 goes into 24? Yeah, that sounds right. So, I guess I did too fast. So multiply the 8 by 3, and so the numerator by 3, and the 6 times 4, and it's the top number by 4. And now we could add up all the numerators. So we have 9 24ths, 9 24ths, 20 24ths, and another 20 24ths. What do we get when we add all those 4 numbers, 4 numerators? 18 and 40, looks like 58. Okay, so again, that's an improper fraction. We want to change it to a mixed number. You can also reduce it. And again, here there's different choices in math. You could reduce it first and then change it to a mixed number. Or you could change it to a mixed number and then reduce the fraction. Totally up to you. I'm going to reduce it first. So divide them both by 2 first. I wrote a note there. Then reduce and change from an improper fraction to a mixed number. or change to a mixed number and then reduce, your choice. If I'm dividing by 2 first, that gives you 29 over 12, and then divide 12 into 29. 12 and 29 is twice the remainder of 5. Hopefully I remember to put the units, which is, in this case, what is it? Inches. So 2 and 5/12 inches. Okay. You might want to, if you want to watch the next video right away, the next one's going to be on subtraction with fractions, which goes real well with this one. You don't have to go ahead and do your homework right away unless you have to do that with your homework right now. But for more problems, we'll just see the next video. Okay? I'll see you here for the next one. Bye.